So we're starting today with a substitution. And this is going to substitute into the other equation. And then there'll be a bunch of multiplying of, the distribution part. You have to distribute the 3. And then you'll have one master equation. So I'm taking out the y here. And I'm replacing it, or substituting, a x minus 4. Now, I'm just going to move this equation up here to keep it out of the way. Y equals x minus 4. It's still true, but I just don't want it in the way as I solve it. Okay. Now, I'm going to distribute. Take a minute, see if you can solve this system. Zane, could you multiply it out for me, please? The distributing part? Nice. And then I'm just copying everything else down. So most of that was just copying down. All right. Caden, take it over from here.
When you combine like terms?
Yep. So the 3x and the 2x make?
5x.
Keep reading.
And then you go minus 12 equals 8.
Perfect. Then what?
And you minus 12 on both sides.
Close.
Or plus 12.
There you go.
8.
There you go. 5x equals 20. Now what?
Divide by 5.
Yep. And then what?
Then x equals 4.
You got it. Okay. And Josh, tell me why I can't stop there.
You have to put that x back into the equation.
Now, can I pick either equation? Yes, I can. You can pick either one. Doesn't matter. So might as well pick the simpler one. That one's simpler. I'm going to put the 4 in where the x is. So the 4 goes there. And y equals 8. Oh, no, wait. 4 minus 4 is 0. Sorry. Y equals 0. And if you left your answer like this, I'd have to cry a little bit and mark it wrong because it's not written right. Sam, do you know what I'm talking about? How am I supposed to write it?
Would it be 4, 0?
Yes, it would. And that's exactly how they're going to ask you to write the answers. Because if you had solved it by graphing, it would be a point. And this is the point where it would be. All right. Now let's talk about graphing. I think it's too easy to graph this, like this type, because then you just see where the two lines cross. But this would be a really important one to be able to graph. Everybody take a minute and graph this, because it's not easy. You gotta have to do like 3 steps first, and then solve it. All right. Remember, test is tomorrow. If you're ever gonna have a big day to pull it all together, it should be today. Henry Kist, can you tell me how to start solving this thing for y? First step?
Minus 2.
Correct. I draw a line that cancels 3y greater or equal, and then if you're smart, right now is the time to put the x in front. It's a little harder, but it's the right way to do it. Cool. Bennett, next up.
Then you divide by 3.
Yep. Notice I do it to all the parts. That cancels. Y is now... Should I switch the sign, Nico? No. Because I didn't divide by a negative. If I divided by a negative 3, then I would switch the sign. I don't switch the sign. And I'm leaving this as a fraction. Don't make it a decimal because we want the rise and the run. And then this is plus 12 divided by 3 is 4. Calculator would have been handy if you're not good at that. All right, now to graph it. I don't need you to pull up graph paper yet. For this one, I'm okay with you just going to 4, putting a dot. And then do you know which direction you would go from there? Riley, can you tell me in terms of rising and running where to go? Down 2 and over 3. And I'm going to say that that's about there. Now again, if you had graph paper, it'd be even easier to tell exactly where to go. But keep doing it, down 2, over 3, and eventually you'd get enough dots and you'd have a line like that. Should it be a solid line? What do you think, Will? Solid or dotted line? Solid. This symbol has an equals in it, so it's solid. And then shade above it or below it, Jaden. This, by the way, is greater than. Above it. There you go. Now, if they asked you for a solution to the system, usually there'll be like more than one line. So let's say I had another line here. I don't want to make you graph it. It'll take too long. And it was like this. And then one last line that like completed a triangle like that. And then you shaded under it. And you realize, oh, the shaded area is right there. If we ask you to tell us a point that's in the set of solutions, you'd pick a point in there. Let's say I grab that one right there. That one to me looks like it would probably be 3, comma, maybe like, let's see, right above that, and that's about halfway above those twos, but that looks like about maybe 3, comma 3. Would you take a second and test this equation and see if 3, comma 3 works? If you don't know what I mean, you need to learn something before tomorrow. See if 3, comma 3 works. It looks like it works because it's in the shaded region, but maybe I misread where that point is. You should be able to take 3, comma 3, stick it in, and see if it works. All right, to save some poor kid from being called on and not knowing what's going on, would somebody be willing to offer how you can see if it works? All right, then you all need to learn something because nobody's confident enough to tell me. So watch this. Oh, Daniel, maybe? Oh, okay, you were just like stretching or something. All right, so this 3 here is the x. I'm going to put it there. And I picked 3 on purpose because do you see that that 3 will cancel with that 3? One's multiply and one's divide. It's like 3 over 3. All right, and then the other 3 is here. Now I'm going to rewrite exactly what I have here. I'm just going to copy it over here. It says 3 is greater than or equal to this part right here. When those 3's cancel, see, this 3 and this 3 cancel out. Now I got -2 plus 4. What's -2 plus 4? It's 2. Is 3 really greater than or equal to 2? All right. It's a choice. Nothing will ever be greater than and equal to. All right? You can't be greater than something and equal to it. But the question is 3 greater than 2 or is 3 equal to 2? Well, it's not equal to 2, but then the question really is 3 greater than 2? Yes, this is true. That's a little scary because they seem like a lot of people are confused on that. This is a true statement. It's either true or it's false. And 3 is greater than 2. All right, so let's say you get to the end of a problem and it comes out to like 5 is less than or equal to -2. You have to decide, is it true or not? Is this true or not? All right, everybody, I want you to think of your opinion. Either write this down, please, and either say true or false next to it. You need to be able to read these and decide, is it true or not? Mara Nordling, what do you say, true or false? She says false. How many of you are on the false team? Raise your hand if you're on team false. You are correct. Because 5 is not equal to -2. Duh, that's easy. 5 isn't equal to it. But is 5 less than -2? No, it's not. It's not. So that's a false statement. All right. So if you were testing to see if the point works, you grab a point and you test and see, when I stick it in the equation, does it work? All right, we need to do one more like that. All right, so imagine I've got my one lines like this. You don't have to draw all this. You're just going to have to use the equations at the end to like see if you understand this. All right, now I'm going to tell you this equation right here was y is less than or equal to negative x plus 4. This line right here, it's the x-axis, so it's y equals 0, but I was shaded above it, so it's greater than or equal to 0. And then this one is the y-axis, so it's x is greater or equal to 0. There's my 3 things I shaded. Do you get the answers in there? All right. Everybody, pick a point that you know would be in there, inside that triangle. What is a point that would be inside that triangle? Nugent, what's your point that would be inside that triangle?
Like 2 and 2.
2 comma 2. All right. Now we can tell for sure if he's right by sticking it into all 3 equations. We're testing to see, does 2, 2 actually work? Well, you're saying that x is 2 and y is 2. So for this first one, I'll test it. Y is 2. I stick in a 2 right there. Is 2 really bigger than 0? Yeah, it is. It worked. So Hugh, it looks like you're right so far. Everybody test 2, 2 in this equation and this equation and see if they're actually correct. Is 2, 2 a solution to this, all 3 equations? Well, 2, 2 is pretty easy. It's like not hard to figure out what to write because they're both 2. X is 2 and y is 2. And so this one's pretty easy. 2 is bigger than 0. That one worked. I usually put like a check mark next to them. That worked. That worked. And how about this one? I'm going to write it. 2 is less than or equal to -2 plus 4. We better actually like solve that. What is -2 plus 4? It's 2. Is that a solution? Yes, it is. Remember, it's one or the other. And this one isn't 2 is not less than 2, but 2 is equal to 2. Check mark. Your point was correct. It worked in all of the equations. Yay. Okay. 2, 2 was actually like right on the line right there. But on the line is okay. It can still be considered in as long as it is in the dotted line. This one was a solid line, so we were good. Okay. Next one, we solve by substitution. Graphing, we'll practice that. I have a worksheet where you can practice the graphing kind. There is this kind where we just have to shade in x is less than 3 and y is greater than or equal to -1. Don't need graph paper. Just make me a little quick graph of this. This is not like, this isn't finding where they cross. This is figuring out where to shade. Now, if you kind of suck at these, which I know some of you do, just do it one little step at a time. Just figure out where x is 3. And put a dot there. This is where x is 3. Now, hopefully you know that I'm not going to run along the x-axis. Then I'd be saying x is 3, and it's 2, and it's 1, and it isn't. It says that it's 3. So here's my line for that, but I just made a mistake. Know what, kid?
Dotted.
Dotted. All right, now it says less than 3. Lance, which way should I shade? Yeah, kind of.
Oh, wait, to the left?
Because, yes, because it's straight up and down, you have to say left. All right, good. All right. Dylan Osberg, tell me where to graph the Y line.
-1, and then it goes across.
Yep. Solid or dotted?
Solid.
Yep. And then where to shade?
Above.
Above. Good. Now, I'm going to ask you to prove that the point 1, 1, it looks to me like it would be like right there. Prove to me that the point 1, 1 is in the solution. Prove that 1, 1 actually is the solution. It's one of many solutions, but so if you're just like, well, it is a solution, that isn't going to be good enough. You have to prove that it's a solution. So you stick in the 1 here, and you stick in the 1 for the y right there. And now I have 1 is less than 3. Is that true? Yeah. And if you get confused on that kind, the alligator eats the bigger one. Okay? So 3 is bigger. The alligator eats the bigger one. That's how you can tell. All right. And then on this one, 1 is greater or equal to -1. Is 1 bigger than -1? Yes. True. If you put a check mark, that's fine, but true is more logical. So they're both true. It was a solution. Yay, we win. Do you get if I picked a point out here, it would not have worked? It would have given me like false statements. The two equations were x was less than 3 and y is greater than or equal to -1. And if I put in the point like 5, -2, or in 5, -3, then when I put in the x is 5, look, 5 is less than 3. That's not true. And y is -3. Is -3 really bigger than -1? You might think it is, but it's not, because warmer is bigger. And if this is like temperatures, -1 is like warmer than -3, so it should have been the bigger one. So that's false also. So that was definitely not the solution. We could tell by the shading, but yes.
On the test, are we going to have to
Prove it?
Yeah.
Yes, that's why I've done it twice today. You have to know that. You can't just say it's in the shaded area. That's not good enough. You gotta stick the numbers in, like I just did, and prove that they're either true or false when you stick the numbers in. Okay, so we've done substitution, we've done elimination, we've hinted at graphing by doing the shading ones, but if you just had to graph two and you graph this one and you graph that one and you find out, ooh, they touch right there, sometimes that's the solution, just the spot where they cross. If there's no shading, then that's the spot. All right, so that's graphing. I'm running out of things to practice with you because I feel like you've got this, but I don't know. On a scale of 1 to 5, 5 meaning I think I've totally got this. I'm going to nail the test tomorrow. On the topics we've covered so far, because there's still the big complicated linear programming thing, which we'll talk about one last time. But on the stuff we've covered so far, are you at a 5, totally get it, or a 1, I'm really lost, and I won't call on you based on your answer? Give me the 5, 4, 3, 2, 1, please. On a hand. Jaden, you too. Give me it. You can hide it in front of your chest if you want to, but I need a 5, 4, 3, 2, or a 1. 5, I totally get it. Down to a 1, I'd suck at this. All right. Thank you for your honesty. All right. Judging from the vast majority of the hands, I'm looking at probably a 4.5 average on that stuff. All right. Then the last thing is this. We're going to have a bunch of kids that are going to a concert. Okay? And and it's based on age. If you're over 18, you're considered an adult. And the adult price to go to the concert, concerts are really expensive nowadays. Let's say it's $85, and that's not even like a super fancy headliner person. Adult, $85. The student prices is only $35, way cheaper for students. Now, the first thing you'd want to pick is what's X and what's Y. Let's all make this the adults be X and the students be Y. And let's say that this was a big concert, and so they made a lot of money. Let's say that they made $10,000. Can you write the equation for that? They made 10,000. The other equation goes with this. There were 700 people at the concert who paid to get in. Zane, do you think you got the 10,000 one?
Yeah.
What'd you say?
85x plus $85.
You got it. And I want you to like notice something, you guys. This part right here was about money. Oops, I just screwed up. That should be 35. Why? Okay. This part right here is money, and this part right here is money. You put all the money into the same equation. If you thought it equaled 700, you'd have money here, and then this is people, and that doesn't make sense. Money, money, and people? No, you put the money with the money with the money. These are all three about money, so they all go in the same equation. All right, the other one's about people. Esh, you think you got that one?
Is it x plus y equals 700?
Yep. This is about people, adult people, student people, 700 people. Yeah. Now, if you were given a choice of which system or which way to solve this, graphing, probably not, because you have to solve for y, and the top one would be really gross. Okay, how about substitution? Well, substitution could totally work, and so could elimination. All right, so I'm going to get to imagine that we just got done graphing this long, complicated problem, and it looked like this. And from the shading directions, this one was shaded on this side, this is shaded here, and this is shaded here. You don't have to copy all this down, it'd take too long. I'm going to tell you that that vertex is at 7, 1. That vertex is at 7, 9. And that vertex is at 3, 0. On those linear programming questions, they often ask you to tell which one gave you the most profit. Let's say that our profit went like this. Our X profit was $20. We make $20 on each one we sell. Our Y profit is $30. Can you write the optimization equation for X and Y? And then can you tell me which vertex wins? The way I would organize that is I'd make a list of your vertexes, the vertices if you want to be grammatically correct. And over here you figure out the profit. You do not have to copy all that down. All you'd have to make for me is that. Look at each vertex, see how much profit you'd get. It would really help a lot if we had the profit equation. Phoebe, can you tell me what you think the profit equation is? Hint, it involves X and Y.
Equals X plus Y.
Close. But you didn't include the money.
20x.
There we go. 20x, 30y. Now, with that profit equation, can you figure out how much profit 30 gets you? You can. Figure out how much profit 79 gets you, and figure out how much profit 71 gets you. This is one of those more advanced skills, but I think it's doable. I think on the test, I think you could handle this one. You could get the 5%. How much does 30 get you? How much does 79 get you? And how much does 71 get you? Jaden, would you please do the 30 for me? I'm going to write the equation in here. Tell me what to do. Profit is 20x plus 30y. Now what?
You plug in the
Yep. 3 goes where?
next to 20.
Yep. 3 goes there. And how about the y? My writing is kind of sloppy. This right here is a 0, so it's 0. Okay, so putting a 0 there. Now, can you do that one in your head? 20 times 3 plus 30 times 0?
60x.
You got it. It's 60. And the 30 times 0 is just 0, so it's just 60. So the profit, $60. Figure out the other two. See which one wins. So 20x plus 30y. Mara, Haley, would you tell me what to put where on this?
Put 7 in the X.
Yep.
And 9 in the
Have you done the calculator work yet?
I'm
Or-
doing it right now.
Okay. I'll come back to you and maybe you can tell us what that comes up to. All right. Alex Wilhelm, 20x plus 30y. What goes where?
7 to 20x.
And?
No 1 to 35.
All right. Would you be in charge of multiplying that one out, please? Maura, what'd you get for the 20 times the 7 and the 30 times the 9?
140 plus 270.
Yeah, what is 140 plus 270? Take a second and give me the final.
It's 410.
410. A lot more profit than 60. Okay. Did you get the last one?
Yeah.
140, 30. What'd you get? So 140 plus 30, I think 170, I think. Does that make sense to you? 70 times 2 is 140. Plus 30, 170. There's your 3 choices. Now it's just which one's the most profitable, and that makes it pretty clear to me. That one wins. 410 wins. Okay, so that's one of the hardest skills. And now I want to leave a lot of time for you to work on a practice. It's a review. I would call it a practice test. If I was in charge of naming it, I would call that the practice test. So the review sheet there, I'm gonna be okay with you skipping any 3 problems on there, because I wanna keep the assignment reasonably sized. But you should be really smart about which ones you skip. You should not go to problems that are like, oh, I don't know how to do this, I'm going to skip it. That would be the stupidest one to skip. stupid, this is probably not the right word, but, you know, my point is, you should do anything that scares you, and then check the key on that. The ones that are super easy for you, but might take a long time, skip those. Skip the ones that will cost you a lot of time. But ones you don't understand, you need to do that, and you need to check the key for it. All right, please tell me that there is a PDF worksheet. I think there is, right?
Yeah.
Okay, then that's what you work on. Please come up and ask questions. So this morning was the morning help morning. So I did have a few kids come in. That was smart. But tomorrow morning is not one of those mornings. Tomorrow morning is not a morning you come in for extra help. So now you're stuck with just today's review video and yesterday's review video. Both of those would be the best things you can do to get ready for the test. All right, that's all I got for you for today. Test is tomorrow.